Okay, in this video we're going to look at the relationship between the three sides of a right-angled triangle here, which we've coloured blue, yellow and red. We're going to draw a square here in such a way that we can arrange 4 copies of the triangle around the square like this. And what we're going to keep careful track of is the amount of empty space left over inside the square, which right now is this red area in here, the square made by the red side of the triangle. Then we're just going to rearrange the triangle's positions within the square like this. Now note we haven't changed the size of anything, so clearly the amount of empty space left over in the square hasn't changed. But this time it's made of 2 little squares, the ones made from the blue and yellow sides. And so it only makes sense that the total area of the blue and yellow squares put together is the same as the area of the red square that we had before. So if we come back to the original triangle, we can picture it like this. If we make the blue and yellow squares from those 2 short sides, and we make the big red square from the long red side, then adding up the blue and yellow areas must equal the red area. In other words, the 2 small squares on the right-angled triangle add up to the big square. Now, given any right-angled triangle, how do you easily know which one is the big side? If you can spot the right angle here, it's got to be the biggest angle in the triangle, which means it shoots across to that longest side. So to locate that longest side, just shoot opposite the right angle, and that will be the one. We call that longest side the hypotenuse. So let's see some examples of this in action. We start with a triangle with the measurements shown. The first thing is always to locate that longest side, the one opposite the right angle here. That tells us that the 2 and the 3 are the little squares. So we can get their area by squaring 2, so 2 times 2 is 4. And squaring 3, so 3 times 3 is 9. We know that these 2 little squares add to the big square here formed by the red x side. So we have 4 plus 9 equaling 13. Now that's not x itself, that's the area of the square formed from x. So to sort of undo the squaring that has happened, we can use a square root, meaning that x is the square root of 13. I'll just leave it here like this. If we ever ask for rounding, just punch it into a calculator and round as you need to. Okay? Last one we'll do here is a very similar problem, which will start again by finding the hypotenuse, that longest side. We shoot across from the right angle and find it's the 13 this time. So what are our 2 little squares? We have 12 square being 144 and y square being some unknown number. But we know that they add up to 13 square, which is 169. So to work out what goes in the y square box, we can just do 169 minus 144, which is 25. The subtraction makes sure that the 2 little blue squares correctly add up to the 169. So again, we can find the side length y by undoing the square with a square root. And so we take the square root of 25, and this time we get a whole number 5. So this relationship between the side lengths of a right-angled triangle is called Pythagoras' theorem, named after a guy who traditionally is known as some kind of mathematical cult leader, which is all kinds of messed up but kind of cool. So anyway, thanks for watching. See you around.